All right. So today we start chapter 4, and we're going to spend our time looking at, I guess, probably the most important aspect of finance. The most important, I guess, formula in finance, I think. Maybe Greg, Dr. Moore would disagree with me, but does anybody know what the most important formula in finance is? Take a stab. Time value of money, yes. Time value of money concept. So some of you have seen this in other classes. Others may have not seen it much at all. And this really tees us up for the rest of the materials that we'll be looking at because of the importance of bonds and borrowing. So, and then we'll get in a little bit deeper on different types of financial instruments that effectively use the time value of money. So, let me start this here. So I'm going to take a little bit different approach. The book, by the way, does some great examples. I mean, they actually teach it about the way I teach it. So I'm going to start a little more broadly than what the book approach is. So then when you get into the book material, I think you'll see how that applies by taking what I think is probably the most general framework for analyzing any investments. All right, questions before we start? All right, so for any investment, I like to think of breaking an investment into 3 parts. So any financial investment can be broke down into 3 simple parts. The first part is called the initial investment. The initial investment. And this is the outlay of cash on day 1. So time period 0. Right? So when we think about time period 1, that's after 1 month, 1 quarter, 1 year has elapsed. So the initial investment takes place now. I just shelled out some money, the timer's ticking. Right? I want to start to, now the rate of return on that investment is dependent upon how much time has elapsed and the amount of cash that comes in after you let it out of your pocket. So the initial investment. Maybe I'll feather in a little bit of what this chapter talks about. In this case, it might be the price of the bond. So, for example, the price of a bond. And that's the direction that the chapter takes. What that doesn't take into account is some more complex maneuvers that we'll talk about later where you might have leveraged your way into the purchase of the bond. So what if you only put 50% of the $1,000 bond down? So you only had an outlay of $500 out of pocket, right? So we can start to play those games. So again, for any investment, no matter how complex it is, it's going to come down to these 3 simple parts. All right, so number 2 is the operating cash flows over time. The operating cash flows over time. So we've got the initial investment, we've got kind of this OF, the operating flows. So this is the amount of cash spent, or more likely received. Let's see, a little spelling there. In each time period. And the thing to note here is that each time period is treated specially. Don't mix time periods. If you got something in year 2, all of the year 2 stuff goes together. You got some other stuff in year 3, all of that goes together. Don't add those together. So it's not like we're adding all of the flows over the whole time frame in the between. We're going to keep them specially identified by time period. All right, so back to our bond example. To kind of keep in line, this would be the coupon payments. The coupon payments from a bond. So if you have a 5-year bond and it says it's going to pay you $100 every year for the next 10 years on your $1,000 investment, then that $100 is the inflow of cash each year over the time frame. All right, questions on operating flows. Number 3 is the terminal cash flow. The terminal flow, TF. So the terminal cash flow is the final payment at the end of the investment. So we're going to close the door on the investment and whatever that is. So note, there may be an operating flow in that final time period too. So note, there may be a operating flow in that period, in addition to sale proceeds or principal returned. So from our bond example, we get the face value of the bond returned to us at the end. We put in 1,000 10 years ago, and at the end of it, we get that final coupon payment plus the $1,000 back to us. Okay, so the face value of the bond returned at the end would be our example tying it back to bonds. So if we had put our money into a muscle car, maybe a 1971 Chevelle SS, 454 barrel, 4-speed on the floor, we shelled out 10 grand for it 10 years ago. We maybe had to put in some money over time. At the end, we sold it for $14,000. So the sale proceeds we got back was the $14,000 at the end. Okay? So any investment in real or financial assets, maybe we should add that here. The way I've got this, your book really concentrates on the financial stuff, but this is a little more general. Real or financial or real assets can be broken down into these three parts. All right, so questions on that, setting it up that way. So the next most important thing is to create a timeline always. So to me, one of the key points is to create a timeline. It doesn't take too long. You can almost think about this being your model for calculating the problem. And so if we've got 0, time period 0, and then we just go out to here with 1, 2, 3, 4, and I guess 5 years. We have our initial investment lives right here. Our operating flows span the whole timeline. And at the very end of the deal here, counted as the last time flow, we have our terminal flow. That's it. So every time you get into, no matter how complex the deal is track the cash. Track the timing of the cash. So the next part of this discussion then is about how to handle the different timing of the flows. And that's where the time value of money comes in. So right now, all we've done is peg the right buckets, kind of the elements, the general elements of the investment. And so now we need to bring into the discussion the time value of money. So before we do that, I want to list the types of financial instruments that we'll have. So types, this is more specific to the chapter. So types of credit market instruments. And this is we're just going to do these 4 types here. One is a simple loan. So a simple loan is we get some money up front, the borrower gets funds, and then pays back the interest at the end of it. So we kind of ignore time value of money maybe. Maybe it's a 2-year loan and we just say, hey, give me $1,000, I'll give you $1,200 2 years from now. And we don't really have any payments in between or anything, right? Just kind of a simple loan with interest. So with a simple loan, the borrower obtains funds in time 0 in time 0, which we might start using this type of notation, T subscript with a little 0 there, T0. And pays back the funds plus interest in T1, some future time frame. Maybe it's a year, maybe it's a quarter, maybe it's a month. But with the simple loan, we'll just kind of leave it nice and straightforward. All right, number 2. Any questions there? All right, so number 2. is a fixed payment loan. Fixed payment loan. This is the one we're more used to, where we start making payments on the balance over time. So in the purest fixed payment loan, the principal, which is the initial amount you borrow. And by the way, just again, I'm not really hung up on spelling too often, but it's not principles of economics with PLE, it's principal is the interest way with financial stuff. So you want to think that you owe a debt similar to your principal at school when you're in grade school and high school, right? That was kind of the boss of everything. Well, when you owe a debt, that's your boss. You are kind of slave to the lender, right? Slave to the lender, the principal. All right, so fixed payment loan, principal and interest are paid in equal installments. Over the life of the loan. Okay, so car payments, house payments are kind of classic examples. Now, there's all kinds of complicated financial instruments beyond this. This is kind of the traditional level payment loan over time. If you get a house mortgage and you pay a 30-year fixed loan, then you're going to pay the same monthly payment for the next 30 years. Or if you get a car loan for 5 years and the banker sets it up with 4% interest, then you're going to pay that exact same payment for the next 5 years. But then there's all kinds of variations in between there. We can have that interest rate floating. We can have a 30-year loan with a balloon payment so that the balance is called due after maybe just 5 years or 10 years. Your payment was calculated over a 30-year period, but the terminal cash flow for you is whatever balance is outstanding. So if you took $100,000, now this sounds like a crazy loan maybe to you. If you took out a $100,000 house loan and you were making nice easy payments and then you paid off the balance to some amount here, maybe you still owe $95,000 on it, then boom, you got one payment of $95,000 at the end of 5 years. That's called a balloon payment. Right, wow, why would anybody want to set something up like that? But what it usually triggers for most people is a time to refinance that debt again and jump into some other sort of loan arrangement. They generally haven't saved up their own cash to do that. So all kinds of fancier ones. So once we get these into our back pocket, then we can start to get more and more complex. All right, questions on that at all? Now, I want to point out something. Although the payment is fixed over the, let's run with this 5-year payment for your car, the principal and interest are not fixed. What's the relationship there? So think about it. Let's take a car loan for $10,000. You took out a $10,000 car loan for 5 years, and you've got some sort of payments. What is the relationship there, principal and interest? Sawyer?
Because the interest goes on the principal, and then the next year it'll be the interest on the principal, the interest in the year before, and so on and so forth with each one coming.
And what's happening to that principal over time?
It is getting bigger and bigger and bigger.
No.
That continues.
We're actually putting a little bit of, so our fixed payment, let's just say our payment was $500 per month. That payment is made up of principal and interest. And so while your payment stays fixed over the 5 years, the principal and interest does not. Why? So you were onto something there and just got a little derailed at the end. Yeah?
Because a little bit of it goes towards your principal each month, so principal slowly goes down.
Yes.
While your interest
which raises a super important point that you got to keep in mind. What do you owe interest on? The principal, the debt. Whatever you owe that person is the only amount you owe in interest. So the interest is always calculated off the outstanding debt, right? So when you first get the loan for $10,000, the interest is really high because you're paying whatever percent you agreed to, 7% interest on $10,000. But if we've set it up to be this fixed amount, by the time you get to year 4, maybe you've got that thing paid down to $2,000. You only owe $2,000 left on your car. Well, the interest now is 7% on the $2,000. Your payment's still $500, which means a larger fraction of your payment is now going towards principal. So that is an important thing to catch on to that tends to hang some people up as a key point here. So on, let me put a couple notes onto the bottom of this number 2. So key notes. Interest is only charged on outstanding debt. This is your principal. Therefore, the interest portion of your fixed payment is high early in your loan and then low in or at the end of your loan, near the end of your loan. That relationship is not linear either. Now,
I was just wondering if you can always pay more than your minimum, right?
Yes.
Pay part of it.
I shouldn't say always, but for the most part, yes. There are, this is probably a bad time to interject this, but there are commercial loans that set up that there's no prepayment. They actually have triggered it ahead of time that they don't want you paying it off too quick. Most residential loans for cars and homes and all of that, yeah, no problem paying it off early. That's right. Yep. And so extra payment goes towards the principal. So maybe you've heard some of these financial gurus saying, make an extra payment or start paying bi-weekly, or the reason they're saying that is that kind of comes back to this. Interest is only charged on the outstanding balance. So if you make an extra $300 towards your $500 car payment, all of that $300 goes towards your debt being reduced, and therefore it's all kind of your money. It's going towards the debt.
So does that improve your credit score?
Loaded question. Part of your the credit score is very complex, and we're not going to spend a lot of time on credit scores here, but part of that is calculated by your debt to income ratio. And so if your debt is really high relative to how much money you're making, and you successfully pay down some of that through putting cash towards it, then that can improve your credit score a little bit. It's fairly small, but there is a little bit of a factor there. So when your credit score is compiled, if you have a credit card of $2,000 and you have $1,995 charged on it, you don't have much, so that counts against you being that close to your limit. The rule of thumb is about half of your credit max is an okay place to be as far as not hurting your credit score.
So like if we had subsidized loans taken out
Uh-huh.
for a year,
Uh-huh.
and we prepay back before we graduate, does that help establish positive credit?
Yeah, there'd probably be, again, just because of reducing your debt, that would probably help, yes. Yes.
That doesn't go against your actual credit score, does it? Just makes you more,
What, the prepayment?
well, the debt to income ratio, doesn't increase.
No, that does
I
go
thought
against your
it
score.
just makes you look more favorable when getting finance or something.
No. If you have 5 credit cards and all of them are nearly maxed out, that drops your credit score. That does act as a negative factor to it.
Even if you're paying them off.
Even if you're paying them off. Yeah, depending on, if you're paying them off every month, you're probably going to be less of an effect because there's not a balance being carried. Okay? All right, again, I don't want to get too hung up on personal finance type issues because my general philosophy is just to don't get yourself in that position. You don't actually need a credit score to live, but that's a whole nother class of personal finance and Dave Ramsey type stuff. Okay, so that is nonlinear was the other comment I wanted to make. So the P and I relation is non-linear over time. What the heck does that mean? Well, if we were to graph this thing out and look at your $500 a month payment, so we're measuring dollars here, and we'll measure time here, and we go 1, 2, 3, 4, 5. And it's not going to show up quite as strong with a short time frame if you graph this out, but this will get the point across. Your payment stays fixed over the life of the loan, right? So your red line is your payment. That payment is composed of principal and interest, and so I might have picked too low of a number, but let me put a little more teeth into this. If you got a calculator out, let me see what some interest would be on this $10,000 loan. So take I don't know, take 5% of 10,000. This is probably good. If you do have a calculator, pull it out. I'll let you use your phone calculator too if you want, as long as you have it disabled to all other outside influences. 5% of 10,000 is how much? 500. All right. So if we take, what is our monthly interest? Because that's annual, isn't it? Right? Divide it by 12. 4166 is interest. Whoops. So interest, I should put principal here is $10,000, and your interest rate was 5%. Your interest that you owe, big I, is 4166. So if you make your $500 payment, this is going to pay off pretty nicely at 5%. This might turn out to be kind of a lousy example. I'd like this example to be, let's go $100,000. $100,000, and let's be a little more careful about this. I guess this is my problem for winging it. I thought maybe I should have stayed in the abstract. So what is the, at an interest rate of 5%, what's your annual interest?
5,000.
How much? 5,000. And so this is annual. And so monthly interest 416.66, right? We had our 41.66, so we just shifted that decimal place over. Now our $500 payment has, I just wanted to shift this up the scale a little bit. So if this is $416.66, this represents in time period 1 month. The blue is the interest portion of the payment. And the green is the principal. All right, so next month, what do you owe in interest? So this is month 1 of year 1. Next month, what do you owe in interest? What did you come up with? I thought I heard a mumble sound. And this is a little painful, and the thing is, you guys have, if you've done this in other classes, you've likely always just used payment calculators or other things, and it's really helpful if you actually kind of crank through it. What'd you get? 413. Okay, so month number 2, this number ends up being, now you can see how depressing this can get, 413, what is it, Michael? 92. 19. All right. So you just got $3 more towards your balance because you paid it off by roughly what, $85, $84-ish. So you had $84 that reduced your principal from $100,000 down to your new principal. So time period 1 was $100,000. Principal in number 2 was, help me out here, let me get an exact number. We won't spend much more time on this, but 100,000, so we had 99,960 what?
99,916.
16.
Would that be 14?
Yeah, 14 probably. Is that what you got?
I got
16? Okay. So now you're calculating interest on that amount, and that's where we got the 413. So if we were to map this thing out over time, the relationship is not linear, but bowed outward like this. And so even as we get deep into the loan, our amounts of principal are slowly falling, and then they fall pretty rapidly towards the end of the loan. And so your green portion here is the amount of your payment that's going towards your debt. So green is the amount of principal in your $500 going towards debt. And the blue is the interest portion. All right, so nonlinear just meant that we're not seeing the debt fall at a linear pace over time. In other words, we don't go from having our total amount extinguished like this through the orange line. It's not a drop off like that, it's bowed outward. Which, notice, keeps more money sooner in the hands of the lender, right? So it kind of works to their benefit. They kind of like this deal. And so they're not as big of fans as you putting extra principal down that pay it off. So you can force your loan to almost look more linear if you want by making extra payments towards your debt. But if you just let it play out through the fixed payment of the loan, that's the way it's going to look. All right, questions there? Comments? Yeah.
Should be 416. Still should have gone down 30 cents. 416.
Oh, did it just go down 30 cents?
Yeah.
Okay. So good. So let's see. Let's just do it here then. This was still true though, right?
Yes.
So that's right. So then, just to be clear, our interest for the month is calculated as P2 times the interest rate divided by 12. Right? Is one way to do it. You can take the principal times the interest, so 5% times the P2, and you're saying you came up with 416.32. It's even more depressing. We got all of 34 cents in reduction from 416.32, and it does really look like this if you start to put together what's called an amortization table of your house payment over 30 years. It looks like this. So if you can shorten that up, and a lot of the financial gurus recommend a 15-year loan rather than a 30-year loan, and that will shorten up the amount of pain that you go through as you watch your principal reduced by a lousy 30 cents in that first month or that second month or whatever. Okay, other questions or comments? So all of that still stayed the same. Everybody okay with this little calculation? All right. Coupon bond. So that was our second thing, was the fixed payment. So a coupon bond is number 3. Coupon bond. This is your kind of your standard bond. You're going to have. Let me use the same notation as the book here. So it is, in layman's term, an IOU. Right? And the features of it is that it's a fixed payment over time with no principal reduction, as opposed to the exercise we just went through. So in its rawest form, if we just kind of pick apart all the details and the names and we look at it, we're kind of doing something similar to what we did here. There's a fixed payment, but there's no principal reduction. Now, what does that sound like if we were to put it in the context of a loan, rather than if we're hung up with government bonds or residential loan? If we're putting it in context of a loan, what are you essentially doing? Paying a lot of interest, right? So we call that type of loan something that you maybe have heard. A crappy loan. Yeah, that might be one word. Interest only, right? So if you think about it in this context, we've got a loan for 5%, and here's the deal. You just pay us interest only now. In other words, your payment, we're going to lower your payment by about $84. We're just going to require you to pay $416.66 the whole time, right? And then what happens to this little blue range? It grows to being a rectangle now, right? Because you paid interest the whole time. So there's none of this green reduction of principal now. It's interest only. So that's really what a bond is. It's an interest-only loan that you're picking. What's that? There's no green at all. Right. There's no principal reduction. So how that... you pay it off in a lump sum. And so that's what we'll get into with the details of the bond. So that'll be the price of the bond and some of the details of the bond. So at the end of the loan, it's kind of like that balloon payment. At the end, you just pay it back. So you got, if it's a $1,000 bond, you got $1,000 here. The lender paid, or the borrower paid interest over the time frame, and then at the end they had to pay the whole $1,000 back. Yep, interest only. That's essentially what a bond is. All right, so fixed payment over time with no principal reduction. Interest only loan. All right, so here's the components. So we've got, I like to think of it this way. I'm going to draw a nice little picture here. So a bond is really a piece of paper. There is some document that the two parties exchange. And so we have the price of the bond. Let's just stick with the simple little 1,000. P equals 1,000. P equals the price of the bond. And you know what? I should, I want to take that back. Sorry. Your thing had this here. Let's make this FV instead of P. Sorry. Get your erasers out. Might not be the last time. And we can leave this here, but FV is the face value of the bond. I'll just kind of foreshadow the difference since I kind of screwed up putting that up there first. If this is a 5-year bond, it has all the details of the bond are written and known through the face value on this document. But if you hold on to the bond 2 years and you decide you want to sell it, its price will not be likely equal to the face value. The price of the bond in the operating flows over the course of time is going to vary according to the current conditions in the market. We'll talk a lot more about that, but that's the distinction here between the price and the face value. So on the piece of paper, we've got the face value, and you might also note that this was the original amount borrowed. So the original amount borrowed or lended is kind of helpful to think about. So if this was the government selling this, then they got $1,000 in that time frame. Okay, so we've got a time frame that they have. So N is the years to maturity. So N equals 5, where N equals years to maturity. Oh man, I'm sorry it's always tough. I did just recently change books, so you can kind of just do this might be helpful. And it might, because the word face value is still there, but your textbook's only using one letter instead of two, so F.
So it's not FX, it's just F.
It was right. It's not FX. Yes, that was a here. That was a. All right. And then C is equal to $100, and C is that coupon payment. The yearly coupon payment. Okay, and so another piece of details this might have is if this was, dated, if this was from the government, then this would be kind of IOU, love Obama. And Obama signs his name, and it's all official, and it's dated 2014. So Obama's promised to pay back after 5 years $1,000, and in the meantime, we'll make $100 payments on this thing. This piece of paper then is a marketable security. So the bond is something that can be traded on the exchanges and people can buy and sell. So it has been, I guess, blessed and sanctioned by the government in those exchanges that's monitored by the SEC so that people can feel pretty comfortable that this is a legitimate deal. Like it's a governed exchange and there's maybe some official stamp and it looks pretty like a stock certificate. All right. Questions on that one? All right, so last one, number 4, is our discount bond. Our discount bond. So the discount bond, the key here is that the amount borrowed was discounted from the face value. So the amount due at the end is still the face. Amount due at the end is the face value. So for example, the government gets $900 for issuing a $1,000 face value bond. Due after 1 year. So no interest in between. The government got $900, but they're promising to pay back $1,000 once it comes due. So the interest has kind of been deducted off the front end, which makes this look a little differently. The borrower agreed to pay back $1,000 here, but only got $900 here. That's called a discount bond. So just another way of manipulating the numbers. No payments, no coupons, just the single payment. So it's kind of similar to the simple loan. All right, we will call it a day there. See you on Wednesday.
Oh, we're on camera again.
Oh, yeah.